Okay, a bag contains marbles of three different colors with at least 3 marbles of each color. So you don't know how many marbles there, right? Have a bunch of red marbles, okay, and have at least 3 marbles, blue marbles, and then red, okay, 3 different colors randomly selected, okay? So could be any other colors, 3 different colors, okay? 3 different colors, red, blue, and let's say green, okay? Green, at least the 3 marbles in green colors, okay? Now you're going to randomly select 3 marbles. How many different color combinations are possible? How many? Okay. So there are many possible. Just in the list, you don't need to check what is the chance to get 3 red marbles. Okay, you cannot get that information, but we just want to see how many different combinations you're going to get. Okay, so look at here. Now it's possible you get all red, right? Because there are at least 3 red marbles. So it's possible to get all 3 red marbles. It's also possible to get all 3 blue marbles or all 3 green marbles. Okay, so you have 3. Then the next possible, then the next group is you have 2 red marbles. Okay, 2 red marbles. Then either you have a green marble, right? Okay, green marble or blue marble. So 2 red marbles. Okay, right? Okay, so that's possible combinations. Now I think the order doesn't matter. Okay, so are the same combinations. So order doesn't matter. So we always list in that order. Okay, then maybe you can have you have to find a way how to classify. You maybe have 2 blue marbles. Then you have a blue G, right? That's another. Then you have 2 green, and the blue. Okay, so this is the way. How do we, classify them? Okay, then be careful. There's some overlap here. Okay, then it only contains 1. Okay, 1 either only 1 red, 1 blue, 1 green. But if it's only 1 red, you already count it, right? If you're 1 red, then 1 red, okay, then either you have a double blue or double green, so it's already counted, right? Double blue or double green marbles, and then you have 1 green marbles, then you have now see, this is with double counted, okay? So either you have a different colors than green group. So this is already, this is let's see. They're all different, okay? This is only 1 should be counted. Those already counted, okay? 2 double G and 1 R, okay? And then the same 1 blue marble, then you have a double red and a double green, and then you also have a different one, okay? And this already counted, and the double G1B, it's already counted, double red and B, it's already counted. So you're not going to get more than and then that, and then the green and 1 green, right? And then double blue marble, double red marble, and they're all different. Okay, so this already counted, and this is already counted. Okay, so clearly you only have this. So you have 10. Okay, so you have a 10. So those are all the possible possible combinations. Right. So don't count the, don't double count them. Okay. So this is I don't, yeah. Sometimes when you want to count how many triangles there are, how many, you just need to classify them into different, satisfying different given condition. Like, this is if I ask you to count how many square there are, you just need to count the square was 1 by 1, square 2 by 2. Then in each category, you get, list all of them. Okay, then add them together. Okay. So similar question here is like, yeah, for example, I have a 1, 2, 3, 1, 2, 3. Let's add another one, 4, right? For example, this is a 1, 2, 3, 4, 1, 2, 3, 4, 5. It's a 4 by 5, right? And the question is how many square there? Okay, how many square there? There are just too many different types of square there. So to count them, there could be one square like that, right? That could be a square like this, right? So you have to, let's count, right? So you have to count those with the same size and then end together, okay? So first of all, you count those type of squares, okay? 1 by 1 squares, okay? Let's see how many square there. That's easy. It's just 4 by 5. It's going to be 20. There are 20 units square there, right? Then you have to look at the squares 2 by 2, right? 2 by 2, okay, how do you get a square? Square is completely determined by 2 parallel lines with the same distance. Such that, right? And those 2 lines, 2 vertical lines, then they form a square 2 by 2, okay? All you have to do is to count the number of parallel square with a distance equal to, okay? So vertical, yeah, one pair of vertical parallel lines and one pair of horizontal parallel lines of equal distance that form a square, okay? So how many pairs of parallel lines, horizontal parallel lines, with a distance equal to, okay? You have 1, 2, and 3, okay? And how many pairs of parallel lines, vertical parallel lines, with distance 2? Then I think there are 4, because 1, 2, 3, 4. So total is going to be 12. There are 12 square there. Then you count those with those 3 by 3. And by same idea, there will be 2 times 3, which is 6. Okay, there are 6 such square there. Then you count those 4 by 4. 4 by 4 is 1 times 2, so it's 2. So now you just decrease by 1 each number, okay, in the product, previous product. So add them together, the sum is going to be 20 plus 12 plus 6 plus 2, okay? Then you get, how many of that here, right? So 6 plus 2 is 8, 8 plus 12 is 20, so 40, there are 40 square there. Okay. So you have to, you count things based on some given condition, classify them into different categories. Then you count them the same type, okay? So this is about counting. The counting is also related to probability. That's the first step. Sometimes we want to calculate the probability. We have to do counting first. Okay. So here's the next problem is about counting. Is about the factors. Okay. Remember, yeah. How do we find the factors? Okay. So here's a question. How many factors does the number, for example, 38 have? Let's begin with this problem. Okay. Now, how do we count the fact? Any number which you can divide the 38 to get the integer is called a factor. Okay, a factor. So the obvious is 38 is going to be 38 is a number. Is going to be 2 times 19. So there 19 is already prime factor. So you can have only 4 factors there. 4 factors. 38 has 4 factors. Okay. So first factor is 1, 2, 19, 2 times 19. Okay. Now you can also describe it in a different way. The factor must be in the form. Okay. And here P can be 0, can be 1. Q can be 0, can be 1. Okay. So yeah, Q cannot be larger than 2, larger than 1. So you have a freedom of choices in the P. The 2 possible ways to get P, 2 possible ways to get Q. So that's why you just need to count how many pairs of such numbers there. Each pair corresponds to a factor of 38. So P has 2 choices, Q has 2 choices. So then they are 2 by 2, which is 4 pairs of PQ. Okay, so that's for their 38 has 4 factors. Each pair corresponds to a factor. Okay, right? So now, let me ask you how many. Yeah, that's how many. How many factors does, I give you a number, just a second. Does 144 have? Okay, so please do this problem. Jim says 15 factors. All right, let's look at. So 144, let's do the factor. 144, everybody knows this is going to be 12 times 12, right? 12 times 12 is going to be 3 times 4 and 3 times 4. Then I got 3 squared, and 2 to the fourth power, right? So a factor must be in the form in the form 3 to the power p and 2 to the power q, where p has choices 0, 1, and 2. Q has choices 0, 1, 2, 3, 4. Okay, so but each factor corresponding to a pair of such numbers, and where p can be 1, 0, 1, 2, q be 0, 1, 2, 3, 4. Now, how many choices for p? There's 3. How many choices for q? That's a 5. Therefore, there are 3 times 5 such pairs. Okay, so each pair corresponds to a factor. Okay, so therefore there are 15 factors. Okay, so let's do one more problem. That was in 2016. So the question is, how many positive integer factors does 2016 have? Okay. So you have to do the prime factorization. Now, how do we factor it quickly? 2016 is 2000 plus 16. 2000 is divided by 100, so it's divided by 4. 16 is also divided by 4. So you can try to, clearly it's divided by 4. So that's why you divide by 4, okay? 2016 divided by 4 using calculate, it's going to be 4004 times 4. Okay, 5004, 504. 504 is still an even number, but I think it's divided by 4. The reason is 500 is divided by 4 because 100 divided by 4. 4 is divided by 4. So you can try 4 again. So it's going to be 126 is 4 times 4. Okay, and the 126 is going to be divided by 2, but not by 4, because 126 is 100 plus 26. 100 divided by 4, but 26 is not. Okay, so divided by 2, and then it gets 36 times 2 times 4 times 4. Okay, 36, 7 times 9. 9 is 3 squared. So how many 2s there? 1, 2, 2, 2, I think 2 to the 5th. Okay. So now you have 3 factors. 3 prime factors. 7, 3, and 2. Okay. So for 3 prime factors, oops. David says, oops. Okay, so a factor must be in the form 7 times 7 to the p, 3 to the q, 2 to the r. And here the choice is, this corresponds to a troop of numbers where p could be 0 and 1, q could be 0, 1, 2, r could be 0, 1, 2, 3, 4, 5. Okay. So how many choices for P? 2. 3 choices for Q, and there are 6 choices for R. So therefore, there are 2 by 3 by 6. Okay, 36 triples of such numbers. Okay, each of them corresponds to a factor. Okay, therefore 2016 has 36 factors, not 18. Okay. All right, so that's enough for the factors. Now let's do some probability problems. Okay, as long as you know how to do counting, then you can solve the problems. Okay, we have a 3-digit number. Okay, for which each digit is 1, 4, or 7 with repetition allowed. Okay, it's going to be chosen at random. Okay, so what are we going to do? What is probably the sum of 3 digits is 12? Okay, wow. Now, how do we make 12? This is tricky here. Well, 12, you see that 1 plus 4 plus 7 could be 12, right? But don't forget, 4 plus 4 plus 4 is also 12. That's it. Using those digits. You can repeatedly using the same digit. Okay? So 1, 4, 7. Okay, 1 way is not. 1 plus any other numbers, right? 7 times 7 plus 7 is already 14. It's larger than 12. So to define the probability, you have to look at all the possible outcomes. Look at that. You can use any of the digits here, right? So how many choices for for the first one? There are 3 choices because you can use one of any 3 digits. How many choices for the second one? You have 3 choices. How many choices for the third one? You have 3. So total, you have 3 cubed. This many possible 3-digit numbers. Okay, using the 3 digits. Okay, repeatedly. Okay, so how do you calculate the numerator? How do you calculate the numerator? I give a minute to think about. Okay, what do you got? 7, Toby says. All right. Okay, so let's see. Emma, you said no, son. Can you give me an answer? Is 7 correct? 7 over 27? Yes, you can use 3, okay? In order to get 12, you either must choose 3 different digits here, 1, 4, 7. So that will be 3 factorial, meaning. Another choice is 4, 4, 4. So it's only 1. So that's all two possible outcomes, design outcomes, right? So 7 over 27, okay? All right, so now let's look at the next problem. If a positive 2-digit number is chosen at random, there are not many there, right? But please understand the question, yeah, before you solve the problem. What is the probability that is that and its digits differ by 1? Okay, not different by 1, okay, differ by 1. Can you try? Okay, so the denominator will be the number of all possible outcomes. How many digit, 2-digit integers there? Right? 90. There are 90 digit integers there. I put the 90 there. Okay, you have to, we can simplify, but 90 should be in the numerator, in the denominator. So this is number of all possible 2-digit numbers. Okay, now you should look for those their digits differ by 1. Okay, can you count? Anyone? Can you give me an answer? (15 over 90, Toby says. Any different answers? Are you working on this problem? Howard, Emma, Karen, Michelle. You see, that's the point. What does different mean? Again, a different means 12, right? This two-digit number, that digits differ by 1. They're not different from 1, different by 1. Okay? Yes. So 32 is also, okay, that digits differ by 1. Okay? The difference could be 1 or minus 1. Okay? So how do you count them? 1, 12, 23, 34 all the way to 89. Then the backward will be, yeah. Then will be, yeah, then you also count, sorry. Hold on, I'm going to erase it. All right. So first digit must be 1, okay? Or cannot be 0, sorry, cannot be 0. But when you change the order, right? So it could be 1, 0, 2, 1, 3, 2, all the way 9, 8. Okay? Then you can see that there will be, first of all, 8 in the first row, but in second row there'll be 9 there. So that's why 17 over 90. Yes. Okay. All right. Now, before do the next problem, let me go over the formula. The number of, for example, teams or groups. Let's use the groups. Okay, not necessarily form a team. The number of groups of K members selected from a group of N members is given by N factorial over K factorial N minus K factorial. Okay. So how do we get that? You should understand the proof. Because the group, when we talk about group, the order doesn't matter. So you have a bunch of members, P1 all the way to PM, right? You want to select the K members, K, right? So with 1 by 1, you put them in a row, first of all, they count, if the order counted. So for the first one, you have N choices. Second, we have N minus 1 choices. The last one is N minus K minus 1, okay? So total, if the order is counted, then you have this many, different rows you can get. However, yeah, this can be also written in the N factorial of N minus K factorial, okay? However, the order doesn't matter, so in that case, if the order doesn't matter, then you have to divide by N factorial, because when you permutate them, you don't see different groups. So that's why you get, yeah. So in this case, this is the number of rows, okay? Is given by this. The number of groups is given by this formula. You have to divide by K factorial, okay? So this is the idea. Okay, we needed this information. Okay. So now we have a bag that contains 7 red tiles and 3 blue tiles. Okay. If 2 tiles are drawn from the bag at random, okay, without replacement. Yeah, that make a difference. The replace here the above one, you know, we don't, you know, without replacement. Okay, what is the probability that the tiles will be different colors? Okay. Express your answer as a common fraction. So now you have 7, right? Red tiles and 3 blue tiles. You randomly pick up a 2. Okay. So you form, so here's the order doesn't matter, right? Form a group. Okay. So the number of pairs. Okay, the total number of pairs. Okay, when we're talking pair, we mean that we don't count the order. Okay, otherwise we said ordered pairs. Okay, so total number of pairs is going to be 10 factorial. Total is 10, right? And then select 2 factorial, and the 10 minus 2 factorial. Okay, so this is going to be 10 factorial, 2 factorial, 8 factorial. After you simplify, it will be 9 times 10 divided by 2, so 9 times 5. Okay. Okay, so this is the total number of pairs of factorial. That will go to the denominator. Okay, the question is how many, the number of designed outcomes, so which is the number of design pairs you want. Okay, different colors, right? Red and the blue. So order doesn't matter. You can always say red is on the left, blue is on the right. Okay. So how do you count them? Well, you can always put a red on the left, blue on the right. Okay. So how many choices for the red one? 7. How many choices for the blue one? 3. So 7 times 3 was the number of this design pairs. Okay, so the probability will be 7 times 3, 9 times 5. After simplifying, it will be 7/15. Okay. So yeah, this is those are the problems, probability problems we're going to discuss. Now I'm not sure whether you finished the homework. So about the homework, okay? Please don't do the last minute. First of all, I know that some students started the homework when sitting in the car coming here, okay? And when you get home, you know, trying to, once you receive the homework and trying to do some of as many as possible. The minimum requirement is finish half of them, the first half. You know, usually you get 60 problems or 80 problems, right? Okay, so I'm going to discuss some homework problems, okay, which just skip. Okay, that means it take you a few seconds, you couldn't figure it out, okay? So the first problem, what number multiplied by 7 is equal to 1 more than itself? Okay, so when you have to translate them into an equation. When you say what number, that's called x. X multiplied by 7, okay, is equal to 1 more than itself. Itself is x. 1 more, add the 1, just, right? So you have to write down like that, okay? So
that's what I did, but then I tried to solve it. I couldn't find it.
So 7x equals x plus 1. You move x to the left, you get 6x. Then x is going to be 1 over 6. Okay, so 1 over 6 is the solution. Now the next problem is if a minus s minus c equals negative t minus b and s equals t, okay? What is the value of a plus b? And express it in terms of a c, right? Well, just look at the first equation, right? A minus s minus c negative t minus b, so you have to move the b to the left-hand side, move the rest of them to the right-hand side. So when move b to the left-hand side is a plus b, and move everything to the right-hand side is plus s plus c minus t. But s minus t is going to be 0. Why? Because s equals t. So the answer is a plus b equals c. Okay? So the sum of those two numbers are expressed in terms of c. Okay. Our next problem is a geometry problem. Square ABC is partitioned, okay, A, B, C, D, okay, into 9 congruent squares, was center square partitioned again into 9 congruent squares. What is the fraction part of the square ABCD is green color, okay? So the idea is I pick yellow color, okay? Yellow color. Then the one in the middle, you partition in the same way, but this time the 4 corners are yellow color, okay? So the question is, what fraction of part of square ABCD is yellow? Let's use the yellow color, okay? Right? So you can assume this larger square is a unit of square. So all you have to do is to figure out if this side A, for example, right? This side is A, and this I'm going to call the B, the other one called the C, okay? So B is going to be 1/3 of A, right? And the C is going to be 1/3 of B. It's going to be 1/3 of, and B is A/3, so it's going to be A/9. So now you just add them together, right? Okay. So the area of the region in yellow color, okay, you just add them together. You get B squared, twice of B squared, and plus how many little square there are? 4, so 4C squared. Okay. Okay. And each of them should be expressed in terms of A. So B is going to be A/3, C is going to be A/9, and square. Okay. So you get 2/9 A squared, and here's 481 squared. And get a common denominator. So 9 times 9 times 9, here numerator times 9, so 18 plus 4/81. So it's 22/81 A squared. So why is somebody get 23? I don't get it. Why you guys get 23? 18 plus 4 is 22, right? Can you confirm that, Tobias? Right, 22/81. So A square is the total area of the largest square. So that's why it's 22/81. So this will be the answer. So the area of the region in yellow color is going to be 22/81 times A square, which is the area of the largest square. All right, let's review a few things because just you probably forgot the relationship between lines and slopes, right? You stop doing any problems after that. Now let's show them. You even check the answer. Let's go back to the, oh, I'm sorry. My picture is different from the one on the book. That was in the middle. I did not mark it. Okay, otherwise it'd be fine. That's additional one. The picture is different from the one homework. That's the reason. Okay? Yeah. Yeah, I did not put the colors in for the tiny one in the center of the square. Yes, there is a square in the middle of the homework, which is yeah, let's go back to okay, let's see. My next question is right, so if a fair coin is tossed 3 times, okay, what is the probability that heads shows once and tails shows twice. Okay. So each time you record it, you get 3, right? Every time, right? So you can either get H and a tail, right? So that, you get maybe HTH, maybe THH, for example, right? The total number of outcomes, possible outcomes, will be 8, okay? So the denominator is going to be, because each time you have 2 choices, 2 times 2 times 2. Now, how do you calculate the numerator? Just count, right? I'm going to ask you to do slightly more complicated problems. That's 2 times 2 times 2. Okay. So we want to get exactly 1 head and 2 tails, right? So 1 head, 2 tails will be 1 head, 2 tails, and 1 head, 2 tails, 1 head, 2 tails. There are only 3 possible outcomes. Okay, right? So the answer will be 1/8. Okay. So now I'm going to ask you to do a similar problems. Okay. If a fair coin is tossed 10 times, about like that, okay? What is the probability that hits show exactly 3 times? Oops, 3 times. Can you do that, right? Now we have a many toasts, right? It's toast 10 times, not 3 times. Okay. Can you do this problem? Yeah, today we focus on probability. We hope we do that. Just vote. All right. Well, the denominator, you write, you get 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 2 more. All right, so those are 10. So you record it, right? So each time you put in your row, right? Each time you have 2 choices. It's 2 times 2 times 2 all the way to 2. So you have a 10 twos here. So how do you figure out the numerator? Hello, get it? Can you get it? You see, you have to change the way you think about, how do we figure out, say in the first toe, right? So this is coin, right? So let's position 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. You just call them 10 people. Okay, different people have different names. The first one called number 1, the second called number 2, right? You want to exactly get 3 heads. So you don't know which 3. Could be this, could be that, could be this. So that means the person number 3, the person number 6, the person number 8 have an H. Okay, so the rest of them have a T. So this is the equivalent to saying, so not, you just call 3 people, right? As a group. This group of 3, okay, get an H. So the total number will be, think about this is the same, yeah. Each group of these 3, each person has a name. The first person called number 1, second person called number 2, right? And to get 3 H's, it's equivalent to find a group of 3 people. Okay, right? So that means you're going to select 3 to form a group out of 10. So 10 factorial over 3 factorial 7 factorial. Okay. Okay, this is the how do we get. Okay, so 7 factorial is this can be 8 times 9 times 10 divided by 3 factors 2 times 3. Okay, you cancel this and you cancel this 4. It's going to be 120, and then you have a 2 to the 10th power. Okay. Yeah, you can simplify this number further. Okay, think about that. Like how do, if those 10 people stay in a row, right? And you want to pick up a 3 to give them edge. So, right? And the rest of them get a T. Okay, so in other words, it's equivalent to saying that it's going to select 3 out of 10. Those selected person get H, but they still go back to the line. It's person called number 3 still go back to number 3 position. The person called number 7 still go back to the number 7 position. Okay, so I think it's equivalent to each outcomes, design outcomes with 3, heads show up exact 3 times is equivalent to a group of 3 selected from a group of 10. Okay, so therefore, you just use the formula for the combination, for the committing problems here. Okay, so we have this. Okay, this is slightly more complicated than the one we just discussed in the homework. Okay. Again, I wish you can finish the homework, okay, before you come to the class.